Okay, let's do some mixture problems. So mixture problems are really important. You might see them in chemistry problems, anything with allied health, medicine, nursing, anything like that. In the food industry, you may see a mixture problem as we're going to mix two different kinds of nuts and they cost different prices per pound, and we're trying to make a bag of mixed nuts and we want to figure out what the new price should be. So that's an example of using a mixture problem in that way. So let's think about making it actually like a solution. A solution is made up of a solute dissolved in a solvent. Okay, and we know that volume of the solution times the concentration of the solute will give you volume of the solute. Okay, so let's just think about what we have here. So if you have some container with some liquid in it, and maybe you have 10 milliliters of solution, and maybe in that solution there's something dissolved, some solute dissolved. Okay, so maybe this solution has a concentration of 50% salt. Okay, so that means 50% of the solution is salt and 50% is water. Okay, does that seem reasonable? So 50% of the solution is salt. We can do this in our heads. 10 milliliters, 50%, that's half. That means we have 5 milliliters of salt. And then we would have 5 milliliters of water. I'm going to write H2O the way we do in chemistry. So, but what you're really doing is you're saying you take the volume of the solution, 10 milliliters, that's the volume of the solution, and then we can multiply that by the concentration of that salt. Our solute is what's being dissolved, in this case it's salt. The concentration of the salt is 0.5, and then if you multiply, you're going to get the volume of salt in that container. So we see 10 times 0.5, we do get 5 milliliters of salt. So I think if we talk through it and we use easy numbers, you can understand this, but this is the process we're doing. Okay, so I could change this up. I could say maybe this solution is 20% salt. So that means you would have the volume of 10 milliliters, the volume of the solution, times the concentration of salt is 0.20, and if you multiply that, you get 10 milliliters times 0.2. You see you have 2 milliliters of salt. So hopefully that doesn't come as too much of a surprise. We're just looking at what percentage of the solution actually is solute, which is the thing that's being dissolved. But when we make a solution, often we mix two different solutions. Okay, so if you're mixing something, if you have solution 1 and you do the volume of that solution, and then you multiply by the concentration of whatever solute you're talking about, by this formula, we will be able to figure out what the volume of that solute is in solution 1. So let's say for our example, this is milliliters of salt. But maybe I'm mixing that with another solution. Solution 2, if I look at the volume of that solution, and I look at the concentration of solute in that solution, again by the same formula, I'm going to get the volume of solute here. Okay, so let's just use the numbers I had. So if I end up doing this, and let's say my solute is salt, so what if I had 5 milliliters of salt from this calculation in solution 1, and then I add that to the 2 milliliters of salt, maybe this was solution 2. I didn't say it earlier, but I used the same volume. Volume was 10 milliliters. Concentration of salt was 20%. You see, well, okay, if I have 5 milliliters of salt, and I add 2 more milliliters of salt, I should get 7 milliliters of salt. So that's how we're going to do this. Our new solution also will be considered as the volume of the solution times the concentration of the solute. Let's do a mixture problem. If a chemical company buys a vat containing 100 gallons of 99.5% concentrated acetic acid, how much pure water must be added to get a new solution with a concentration of 5%? So we know that volume of a solution times the concentration of solute gives you the volume of solute for each solution. So if I have a solution and I mix it with another solution, I can get a new solution. The volume of solute in solution 1 plus the volume of solute in solution 2 will give us the volume of solute in our new solution. So we go piece by piece. If a chemical company buys a vat containing 100 gallons of 99.5% concentrated acetic acid. So this part of the problem right here is talking about solution 1. Okay, so read that part again. If a chemical company buys a vat containing 100 gallons of 99.5% concentrated acetic acid, do we know the volume? Do we know the concentration of solute? Read it again to yourself. If a chemical company buys a vat containing 100 gallons of 99.5% concentrated acetic acid, which one is the volume? So I didn't mention it yet. Let's also verify that we know what the solute is, right? We have a solution, and the solute is acetic acid, okay? And the solvent, that's what we're mixing it with, in this case is pure water. We're making a solution by mixing acetic acid into pure water. This is the solvent, this is the solute. So if we want the volume of solution 1, we know there is 100 gallons of solution 1. Okay. But what is the concentration of my solute, which is acetic acid, in this first solution? What's the concentration of acetic acid? Well, we have 99.5% concentrated acetic acid. Okay, but remember, if you have 99.5%, you really can't use that in a math calculation. We need to tweak it a bit. We're going to write this as 99.5. This decimal place right here needs to move 2 places to the left. So the concentration is 0.995. Does that make sense? I'm changing that percentage to a decimal. Okay, so that's the first solution. If a chemical company buys a vat containing 100 gallons, that's the volume, of 99.5% concentrated acetic acid, that is the concentration. Then we're going to do something with that, right? That chemical company is going to add something. What are they going to add? How much pure water? They're going to add pure water. How much pure water must be added? So this is going to be solution 2. Solution 2 represents pure water. What's the volume for pure water they're going to add? Does it say anywhere? Read it again. How much pure water must be added? How much pure water must be added? How much, right? How much is the volume? We don't know. So we are going to identify that by using an X. And it's actually going to be X gallons. Okay. What is the concentration of acetic acid in pure water? What is the concentration of acetic acid in pure water? It's pure water. Shouldn't have any, right? So there is 0% acetic acid in pure water. So if you take 0%, you move this decimal place 2 places, your concentration is 0. Okay? So the pure water part tells me the concentration is 0 from this statement right here. Okay, we're just talking it out. And we're making a new solution, right? We're going to pour in pure water into that 100 gallons. So our volume is going to be 100 gallons plus some more, right? Does that make sense? My volume has to be the 100 gallons plus the more liquid that I add. Okay, we don't know how much we're going to add, but I know my original was 100 gallons. You're dumping in X more gallons, right? Okay. And we're going to get a new solution with a concentration of 5%. Concentration of 5%. So the concentration here is going to be 5%. 5%. So we had 5 with the decimal place right here. We go 1, 2 places to the left. So 0.05. Okay. So now we have an equation. Hopefully this makes sense. The hardest part for most students is this volume part. Think about it. If I have 100 gallons and I add 10 more gallons, the new volume is 100 plus 10, 110 gallons. If I have 100 gallons and I add 50 gallons, you have 100 gallons plus 50 gallons, you'd have 150 gallons. The problem is I don't know how many gallons I'm adding for solution 2. I don't know the actual number, but I know it's x, right? So the volume of the new solution is 100 plus x. So we're going to rewrite this without the units, because notice this is 100 gallons times 0.995. This gives you number of gallons of acetic acid. This is number of gallons of acetic acid. And this is number of gallons of acetic acid. So gallons of acetic acid plus gallons of acetic acid equals gallons of acetic acid. The units should all be okay. So now we're going to rewrite it, like I said, without the units. 100 times 0.995 plus 0x. You can leave it like x times 0, but I like to put the number first. Equals. Okay, we have a rule in algebra that says A times B is the same as B times A. It's the commutative property. And this is true if A and B are real numbers. So we can really flip the order of this. We can write this as 0.05 times 100 plus x. Okay, now we're going to solve this. We get 99.5. That's what you get when you multiply this. Well, 0x is just 0. Okay, and now we're going to go here and we're going to do the distributive property. We're going to do 0.05 times 100. 5 plus 0.05 times x. And then we're going to clean it up. So I'm really just going to move this guy over here. So we're going to subtract 5 from both sides. When we do that, we get 94.5 equals 0.05x. We want the coefficient of x to be 1. So we're going to divide by 0.05 on both sides. Type this in your calculator. This cancels. You get x equals, looks like we get 1890. Okay, so the chemical company must dilute their 100-gallon acetic acid solution with 1,890 gallons of water to get a 5% acetic acid solution. So they actually have a whole lot of solution now. Okay, hopefully that makes sense. And vinegar, most distilled vinegar that you use, household vinegar, has 5% acetic acid. And if you read the label, it says it is diluted distilled vinegar. Vinegar is the main ingredient, is acetic acid. Okay.